So, let me tell you a little bit about our current rover design for the moon. Our first priority, of course, is that it has to be small, very small. Lightweight, less than a kilogram, or perhaps 1 kilogram and a little bit on the moon's surface. We know the issues of getting full functionality into that kind of mass and space, and we're doing our best to actually get everything crammed into such a small one. It has to be, as it's looking right now, a CubeSat form factor, which means 10 centimeters by 10 by 10, possibly more than one, as such. And the design of the moving parts, what is going to drive us on the surface, has all the time in our design been a traditional rover, traditional wheels. However, our initial design was thinking about 4 wheels. However, if you take a CubeSat, this is a 2-cube model, and place a wheel here and here, you have a size restriction from physical points of view that one wheel cannot touch another wheel, such. So we've gone through various phases of thinking about having a 3-wheel or size difference between front wheel and back wheels. Until the latest design we've hit on is a 2-wheel design. Now, 2-wheel design has an issue, which is that it may not be able to move the wheels. It might spin the cube in the middle instead, and the little film we saw from one of the other teams at the last team summit was with a tail on it, so that it had some friction on the surface in order not to just spin the middle part. However, our solution is another one, and I have made a little model which is at this moment in time approximately half size. This one is just around 5 centimeters by 5 centimeters, and I have added 2 balls to illustrate how the wheels might look. Now, this one, as you can see, there is quite some free space underneath, approximately the same size as the CubeSat in the middle, which in real terms would mean 10 centimeters. The form of the wheels is not necessarily a sphere, it might be an oval like that, but this is just to illustrate. Now, the key question has been how a thing like that could actually move on the moon's surface, and the answer to that is that it can move by moving one wheel first, and that might turn this one a little bit. This would then afterwards move the second one, and then the first one and the second one, so it would be a movement like that, and it wouldn't really matter so much if this one was turning or not. And to keep it upright, we might use something much more simple to do that, which is simply to make sure that the mass of this one favors a hanging position with the same part down all the time. So our invitation to the students anywhere in the world, or the University of Applied Sciences in Wiener Neustadt here next month, is to build us the first prototype of a thing like this, with motors inside, build it in real size, so 10 by 10 by 10 cube, and the wheels on. Now, the next thing, of course, after that, you can say prototype number 2, 3, would be to have the wheels inflatable, so that they can actually be sitting inside the cube as it is launched and get blown up during descent on the towards the moon, which means that they can also act as parachutes. Well, not parachutes, that's not the right word. The right word is that they should act as airbags, so that when we fall down we actually do not hurt the electronics and the rest of the things inside our box. Thank you for listening.